All right, so next on our list, area under the curve. So if you remember our normal integral before, we have a to b of y dx. So our y here, though, is y of t. And so if you think about this little rectangle, just like before, that's y of t. And so the area would be length times width, y of t dx. But they don't match. So what we have to do is either solve for y in terms of x so we can plug it in, or rewrite the equation with a little changing of variables to make it with dt. So if we do a substitution, x equals x of t, because that's what our x is, and then we do our derivative, dx equals x prime of t dt, so just a little like u substitution but with an x. We can then substitute our x now, our dx, with x prime of t. So we end with the integral of y of t, x prime of t dt. But now this is not a to b, so I'm just going to call it start. This is our starting t to our finishing t. So it's the t values that are given by those x values. All right, so let's try one. So we want to find the area of the region enclosed by x equals t cubed plus 1 and y equals 2t minus t squared. So I've already got it drawn. This is our region, and you can just use Desmos or your graphing calculator. So if you input it in with the parametric equation, so again, your mode, make sure it says parametric, and then you graph it, we end up with this. And you can see that's where it is stopping right there from here to here. So we end up with this region, or you can use Desmos, which gives us this. And what we're looking for is, again, that basic rectangle so that we can go from the very first t to the very, very last t. And how do you find those t values? Okay, so we need the derivative of x. So with respect to t, dx dt would be 3t squared. And so now we can go the integral from start to finish of y and x prime. So 2t minus t squared times 3t squared, and now dt. So this is our dx right here, and then this is our 2t minus t squared right there. So you can see here that this is our dx is equal to 3t squared dt. And so we're just doing our y dx. That's all this is, y dx. Okay, now we need to start and finish for our t, though. So if you think about how this works, this is our y value here, and we want to know what it is with the x-axis. Well, that's when y is equal to 0 here. This is something comma 0 and something comma 0. They do have x values that we could plug our t value to find in, but we don't need it because we need it with respect to time. But we do need to know is what is that t value here that gives it. So we need that t equals what, and we need that t equals what for our start and our finish. So if we take our y value and we set it equal to 0 because of the x-axis, we get 2t minus t squared. Factor out the t, and we get t equals 0 and t equals 2. And you can verify these again in your calculator. So if you use the trace function and 0, see it's now getting a t of 0, it's right there. There's our y equals 0. And trace 2 gives us that one, and there's our other y equals 0. So from y equals 0 to y equals 0. So now if we take our integral, we get 0 to 2, and then that would become 6t cubed minus 3t to the 4th. So this is 6 over 4, t to the 4th minus 3 over 5, t to the 5, 2, and 0. And so the 0, when you plug into the t, is just going to become 0, so we don't have to worry about it, just a 2. So 3 halves, 2 to the 4th minus 3 fifths, 2 to the 5th. And then if we plug that in our calculator, we get 24 over 5. Don't do that by hand. And if we check with with Desmos, we get 4.8, which is our 24 over 5. All right, let's try another one now. So you can see it's a little bit different now. So now we have it with the y-axis. So if I draw my rectangle on there, it would actually look like this. And so this is now dy, and this is x equals. So we're going to have to take our y and change it into dt. And we use x equals for our function itself. Okay, so if we do dy dt, this is t to the 1/2. This would be 1/2 t to the negative 1/2. So dy equals 1/2. Let's do square root of t, just because. We can change it back later. And then dt. So now if you think about our integral, we're starting here, finishing here. So it would be the integral, right, of our area. So our x, which equals t squared minus 2t. So it would be this one times the dy. So this times dy. But dy is now equal to 1/2 rad t dt. So our area would be this one times this one, length times width. So it's t squared minus 2t, and then 1/2 rad t dt. So basically what we're doing is it's x and then y prime of t dt from start to finish, because we're doing our rectangle horizontal. So I've plugged in my x, I've plugged in my derivative with dt, and now I just need to find out what my starting t value is and ending t value is for my x's, right? So I need to set this right here is x equal to 0. So if I take my t squared minus 2t and I set it equal to 0, I get t equals 0 and t equals 2. So from 0 to 2. And so here we go. There's our area right there. Here's the problem though. If you notice, we want to find the area of this region. So if I were just doing area under the curve, that would be fine. But it's not. It's going to come out negative. You see how it's all red because my x values here are negative. This right here is a negative value, right? It's a negative x value. So what we have to do here is modify this to make sure that our negative stays positive. And so if you remember, we did those difference between regions because we want to find the area of the region enclosed by this. We're trying to find that entire area. So if you remember, this is x equals 0 right there. And so what we were doing is subtracting them. So this width would really be 0 take away t squared minus 2t, like that. So in here, all you have to do is change the signs. And that's going to turn it into a positive instead of a negative. So our length here needs to be turned into a positive, not a negative, so that this comes out positive, giving us the area. You could also just calculate the area and then change the sign. That would work as well. Okay, so now we just need to finish this. So we have negative t squared plus 2t. And then this would become 1/2 t to the negative 1/2. So we're just going to put it back in its other form and then distribute it. So we have negative 1/2 t, and then 2 minus 1/2 is 3/2 plus 1. So then it's 1 plus a negative half, so a half dt, 0 to 2. All right, so then we add 1, so 5/2 times 2/5 plus 3/2, 2/3, 2 and 0. So you have negative 1/5, 2 to the 5/2 plus 2/3, 2 to the 3/2. And then the 0 is just going to make it 0. So this would just become, I have a set of 4 here if you think about it. So I'm going to take out 2 of them. So it's negative 1/5 times 4 rad 2 plus 2/3, 2 rad 2. So negative 4 rad 2 over 5 plus 4 rad 2 over 3. And you can keep going if you want. And then we check our integral on our calculator, and everything's good. Sorry, that was really quick, huh? So I plugged in the integral. You can use t or x. It really doesn't matter. It's just the variable itself. But you should be getting the same answer. And so this would also be 8/15 rad 2. So I guess that is a better answer, so let's get rid of that one. I'll leave it that way. And you can also just plug that in your calculator. They have a common factor of rad 2, so you can just do negative 4/5 plus 4/3, hit enter, and it'll say 8/15.